Start.
So greetings to all the jury members out there. We are from Team Syndicate, and here we are presenting our solution, SafeFarm, which is a solution for the problem statement that is development of a digital farm management portal for implementing biosecurity measures in pig and poultry farms. So before we dive in, I just have to pitch in some points about the scale and scope of the problem. So actually, recent survey from NDLM reveals that India faces an annual loss of nearly 30,000 crore due to the livestock disease outbreaking. And it also reveals that mostly 85% of the farmers literally have 0% awareness on what are these biosecurity guidelines and how to actually implement them. So here we come up with our solution, which is SafeFarm. It is actually a mobile-friendly and web-based platform. It uses the AI and digital tools and helps small-scale farmers and the marginal farmers to understand the digital biosecurity guidelines and use it. So the problem that is being addressed over here is how to build or bridge the gap between the farmers and these guidelines. And our proposed solution, this website is an all-in-one platform which has all the features such as AI risk alerts, visual tools, local language support, and veterinarian supports. And I also have to mention that it works good in both offline mode as well as online mode. And also it simplifies the veterinarian protocols, which is easy for the farmers. And the innovation step which makes this safe farm stand out from other websites is that local language support and veterinarian support, which is onboarding the veterinarian support and also sending some real-time alerts. And we are also coming with some gamified steps, which is user-friendly for farmers, and it gives the instant scores such as low, high, medium. So it helps the farmers to develop themselves. So maybe next slide, technical approach will be explained by my teammate.
This is our technical architecture for SafeFarm, an AI-powered digital biosecurity portal built entirely on open source and scalable technologies. For the front end, we use Next.js. So it's a React-based framework to build a responsive website. It's optimized for low bandwidth and offline first access, which is essentially in rural language. For the backend, we use Supabase Cloud, which gives us PostgreSQL with built-in authentication, role-level security, and real-time updates. So every farmer and veterinary sees alerts instantly. Our AI risk assessment engine runs Python logic deployed as APIs through Supabase Edge functions, while AI early warning predictor uses a lightweight ML model combining farm data, regional patterns, and weather trends to forecast disease risks up to 15 days ahead. We are also planning to add visual diagnosis where farmers can upload an image, and our TensorFlow-based classifier gives preliminary insights before a veterinary review. Next, our gamified compliance system motivates farmers. They earn badges and track progress when following safety protocols, and this may get rewards such as incentives and other insurance such as, okay. And lastly, all this data flows to Supabase SQL views for data dashboards and future integration with the NDLM or NADRS to support policy level analytics. So this full stack from front end to database ensures secure access, real-time communication, and AI-assisted prediction, making SafeFarm technically feasible, scalable, and ready for pilot deployment. Next slide. So coming to the feasibility and viability. So one of the technically SafeFarm is built entirely on open source and low-code technologies, and Next.js for front-end and Supabase Cloud for back-end and Python 8 for risk analysis. Because it's a cloud-based stack, it allows us to prototype quickly, scale easily, and maintain secure access using built-in features like authentication and row-level security. This means even if we deploy for thousands of farmers, it remains stable, secure, and cost-efficient. And coming to operational feasibility, operationally, SafeFarm is designed for ease of use. It's multilingual, which means even farmers in rural areas with low digital literacy can use it. So they don't need any technical knowledge. Everything is explained in simple language, visuals, and icons. And coming to financial feasibility, financially, the project is extremely low cost. It runs on Supabase and Versal, both of which have generous free tier plans that can easily support pilot deployments. So we don't need heavy infrastructure investment to get started, which makes SafeFarm affordable and scalable even for government or CSR-backed programs. And coming to implementation feasibility. In terms of implementation, the MVP is ready with 4 AI models and can be integrated with NDLM APIs, allowing government departments to view analytics, track outbreaks, and use the collected data for policy making and early intervention. So the solution fits directly into existing government system, which improves adoption. And coming to sustainability, we have ensured sustainability by creating future-ready roadmap, like integrating AI-based prediction, IoT sensors, and gamification. This keeps farmers engaged long-term while continuously improving data quality and farmer safety awareness. And of course, coming to potential challenges and risks. Of course, every practical solution has a challenges, and we have identified some of them. The first one which we have identified is the low farmer digital awareness by slow initial adoption. And the second thing is that language diversity of a state require local translation. And third one, limited internet access in villages may delay live alerts. And the fourth one is data validation is crucial to prevent false AI result. And we have identified some challenges and risks, but we have identified some strategies to overcome these challenges, and we have already built some strategies. For digital adoption, I think we will conduct awareness drives with veterinary officers. For multilingual access, we will deploy chatbot and UI in regional languages like Kannada, Hindi, and many other languages. For internet dependency, we are adding offline for sketching, so farmers can use it without full-time connectivity. For AI accuracy, we will use regional data sets and veterinary review look to refine predictions. So overall, SafeFarm is technically strong, cost-efficient, farmer-friendly, and ready for real-world scaling with every challenge backed by practical solution. Next slide.
By empowering small and marginal farmers with simple self-check awareness tools while also connecting them directly with veterinarians for timely guidance. By offering local language resources, it bridges the digital and language gap, making technology easier to use for rural communities. Policymakers also benefit through access to real-time farm data, helping them make better decisions on biosecurity. Overall, this reduces major disease outbreaks, saving livestock and minimizing farmer losses. It boosts farmer confidence, improves digital literacy, and ensures stable productivity and income. At the same time, it promotes animal welfare and sustainable livestock practices, supporting healthier rural ecosystems. Our research and references are based on both government frameworks and international best practices. From the Indian side, we have drawn inputs from the Ministry of Fisheries, Animal Husbandry, NDLM Traceability Deck, which provides AI-enabled early warnings. On the global front, we follow standards like the WOAH Terrestrial Animal Health Code and FAO guidelines, which include good biosecurity practices and poultry biosecurity checklists. Together, these references ensure our solution is aligned with official policies, scientifically sound, and globally accepted practices.
So this is the landing page that we are expecting for our software. So the first thing is you will see our logo, the SafeFarm here. So this is just a basic HTML template. So none of the features are currently working. And that we are offering is the first feature is real-time monitoring and proactive alerts. So proactive alerts is used to receive instant notifications about potential biosecurity threats. And so if someone or a new farmer, if they want to connect with our software, the first thing you have to do is integrate your existing system or use our smart sensors. So you can integrate your existing farm with our current software. And the second thing is how to monitor and manage. So with the experiences or features in the software, you can track health data and environmental conditions, mitigate potential risk. So this is the look of the dashboard inside our software. So the farmer will be seeing the same thing inside the app, and it will also show us the real-time alerts, such as if any high-risk alert is mentioned by the veterinary, the farmer will be alerted with the timely alerts. And the farmer can also get the quick action section where they can start any new assessment related to the real-time alerts, and they can also add the farm details such as the name of the farm and type of the animal count and the location. Okay, and the next thing is records. So if they connect with our software also provides monitoring of security cameras within their farm system. So in here, the digital records will be automatically saved, such as if the routine health check for pigs or any other animals, or if some veterinary doctors did conduct a vaccination treatment against all the animals. So this will store all the logs in it, so the farmer or the admin can access it anytime. If the farmer or the admin have missed any of the alerts given, so he or she can check the alert center, in which the alerts are mentioned with the time here. So the type of the alerts with the description will be shared by the manager or any veterinary doctors, and the date and time will also be provided, so the farmer or the admin can check it out anytime, anywhere. So and the status of that alerts will be displayed here. So that's it.